Brian Spreckley is a champion glider pilot. He's preparing for a high-altitude glide in the French region of the Pyrenees Mountains. Gliders have no engines, and once aloft, he'll be at the mercy of the winds. To get into the air, a plane gives him a tow. Spreckley hopes to ascend to 9,000 meters, about 4 times the height of the surrounding mountains. To succeed, he'll need to find what is called wave lift, which is generated when wind strikes a mountain.
As it comes and hits the mountain, it comes up over, down the backside of the mountain and compresses. It goes down and down until the ground gets in the way. It then must come back up again.
If you have several mountains in a row, as in the Pyrenees, the up wave gathers momentum.
So by the last mountain, the air really travels up very fast indeed, 10 times maybe the height of the mountain.
As he ascends, Brian scans the skies for signs of a good wave. At 2,100 meters, he finds what he's looking for, a patch of saucer-shaped clouds, and lets go of the tow line.
With the cloud shape, we can see the movement of the air. And we're looking for that, and if we have a stack of these, like saucers, stacked one on top of the other, then we have beautiful wave conditions.
When Spreckley hits the wave, his glider begins to climb upward. Spreckley rides the wave to more than 9,100 meters, a new altitude record, and then begins his descent. Throughout the flight, he has been monitoring the weather. Without a precise knowledge of weather conditions, this kind of flying would be impossible.
The power that enables us to glide is the weather. It's the sun, the wind, and all of the elements of the weather.
The wave lift Brian Spreckley rode is an example of a local wind that can usually be found in the Pyrenees. There are also winds that blow on a much larger scale, global winds that humans have relied on for hundreds of years for navigation and trade. How do mountain ranges affect winds and create ideal conditions for gliders? As you watch the following segment, keep in mind the many global wind patterns Ellen Macarthur encounters on her voyage. At the age of 26, British sailor Ellen Macarthur was about to set off on the adventure of a lifetime. A solo sailboat race around the world, more than 38,000 kilometers through some of the world's most treacherous waters. At the time, Ellen was the youngest and least experienced of the 26 sailors, and one of only 2 women competing.
The hardest things of sailing alone are the fact that when something happens, there's no one else to help you sort it out. And no matter how rough it is, or how cold it is, or how dangerous it is, you have to do it.
Beginning in France, Ellen will head south through the Atlantic, travel around Antarctica and up the coast of South America, finally reaching the finish line back in France. As has been true for sailors throughout the ages, Ellen's biggest friend and fiercest foe will be the global winds she'll encounter throughout her journey. Just 3 days from port, Ellen is experiencing 45-knot winds and rough seas. She is sailing through the latitudes where the northeast trade winds, one of Earth's prevailing wind systems, blow. Like all global winds, the trade winds follow a curved path due to Earth's rotation. This is called the Coriolis effect. The trade winds are pushing Ellen steadily south and west, eventually toward the equator.
We've never sailed in these conditions before in heavy downwind, and it's really difficult to know what sails to put up.
Like all weather phenomena, winds are powered mostly by the sun. Its energy radiates out across space to all points, including Earth. But the sun heats some parts of the Earth more than others. Areas near the equator receive the most direct sunlight. Temperatures here are always warm. At the poles, the sun's rays strike Earth's surface at a lower angle, spreading the sun's energy out over a larger area. Temperatures here are much colder than those at the equator. These differences in temperature create differences in air pressure. Around the globe, the hotter, less dense air rises, and colder, more dense air flows down to replace it. This air movement creates winds. In the northern hemisphere, the trade winds blow from the north-northeast. For hundreds of years, trade ships have relied on them to cross the Atlantic. For her race, Ellen is counting on the trade winds to propel her across the ocean. On day 6 of her journey, Ellen learns the winds and her skill have pushed her to 3rd place. It's cause for celebration. A week later, Ellen crosses the equator, an important passage for all sailors.
It's a big thing. You thank the sea for letting you pass, because really we're a very, very small speck on the great oceans.
Ellen is heading into the southern part of the Atlantic Ocean, the most dangerous part of the passage. Icebergs and 15-meter waves, about half the height of her boat, are common.
I'm looking forward to getting down there, but I know it's going to be the hardest thing I've done in my life.
Ellen soon learns firsthand the dangers of the South Atlantic. She is battling 80-kilometer-per-hour winds and 12-meter waves. It is bitterly cold. A sudden gust of wind catches her sail and knocks the boat on its side. It rights itself, but the sail is damaged. The winds causing Ellen so much trouble are the polar easterlies. This global wind pattern forms as cold air near the South Polar region sinks and flows back toward lower latitudes. Ellen will spend a good part of her journey battling these winds and the waves they create. To continue sailing, Ellen must repair her wind-damaged sail. It requires a climb up the 27-meter mast in rough weather.
Freezing cold, your body goes numb because it's so cold, and it takes a long time.
A sudden change in wind could flip the boat, and Ellen with it.
I remember thinking, physically, this is going to kill me. But then, just hanging on and hugging the mast and saying to myself, well, you don't have an option. Just do it.
And she does. By late December, Ellen is halfway through her journey.
Happy Christmas, 25th of December.
She's been at sea for 6 weeks. The waters around Antarctica throw another surprise her way.
Unbelievable, there's a row of 5 icebergs, there's one which just passed really close.
The winds have forced her to sail straight into a field of icebergs.
Iceberg watch.
Ellen gets so close, she can see caves sculpted into the ice. When Ellen finally bids goodbye to Antarctica, she is grateful. She's back in the South Atlantic, heading north off the east coast of South America. The air is getting warmer, the ocean calmer. The southeast trade winds carry her toward the equator.
Good morning, camera. Here we are in the doldrums. We are, as I speak, 2.1 miles south of the equator, so we can probably even see it.
The doldrums, dreaded by sailors the world over, a virtual dead zone for wind. Along the equator, warm air rises steadily. Cool air moves in, but is warmed rapidly and rises before it moves very far. Consequently, the winds here are very weak.
Feel the heat, the wind's died, see the glasses.
When she finally crosses the equator, Ellen's on the home stretch. Less than 6,000 kilometers to go. At 30 degrees latitude, she'll encounter another global wind pattern, the prevailing westerlies, that will propel her back toward France. Ellen's standing in the race is good, 2nd place. Does she ever consider she might actually win?
No, because you don't know that until you cross the finish line. You can't afford to let yourself think things like that.
In February, after 3 months at sea, the coastline of France is in sight. Ellen and her boat, damaged several times over the 97-day journey, limp toward the finish. People all over the world have followed Ellen's progress. Thousands are waiting in poor weather for her to reach dock. Ellen's finish is one for the record books. She is the youngest skipper to sail around the world, the fastest woman sailor ever, and the 2nd solo sailor to travel the globe in less than 100 days. As sailors have done for centuries, Ellen relied on global winds to power her journey. Winds that at times threatened to capsize her boat, and at others had left her drifting in stagnant waters. According to Ellen, the worst part of the ordeal was the moment she had to step off her boat.
I can't explain it. But all I can say is I didn't want to get off and I didn't want to end it. It was the most amazing experience of my life. And the moment I touched that dock, it was over.
What property of wind would explain it being called a prevailing wind? Winds are powered by the sun. Energy radiating from the sun warms the earth, but heats some parts of the planet more than others. These differences in temperature create differences in air pressure. As the hotter, less dense air rises, the colder, more dense air flows down to replace it. This air movement creates winds. The spinning of Earth shifts winds to the west. It's called the Coriolis effect. On her solo race, sailor Ellen Macarthur encountered global winds such as the trade winds, which blow toward the equator, the polar easterlies near Antarctica, which bring fierce winds and rough waves, and the prevailing westerlies that blow away from an area of calm. Ellen also experienced the doldrums, the band of calm air near the equator where winds are very weak. Ellen was able to sail successfully through these global winds. Not only did she come in second, she became the youngest sailor and the fastest woman sailor to circumnavigate the globe. What wind conditions can sailors expect to find in the doldrums? Which winds enabled Ellen to sail around Antarctica? Suppose you are preparing for a sailing trip around the world. Write a description of the types of winds you would expect to encounter. Be sure to include information about what causes the winds.